But in this film, it will be shown that the Earth's climate is always changing, that there is nothing unusual about the current temperature, and that the scientific evidence does not support the notion that climate is driven by carbon dioxide, man-made or otherwise. Everywhere you are told that man-made climate change is proved beyond doubt, but you are being told lies.
When people say, well, you don't believe in global warming, I say, no, I believe in global warming. I don't believe that human CO2 is causing that warming.
A few years ago, if you would ask me, I would tell you it's CO2. Why? Because just like everyone else in the public, I listened to what the media had to say.
Each day, the news reports grow more fantastically apocalyptic. Politicians no longer dare to express any doubt about climate change.
There is such intolerance of any dissenting voice.
Are some of the worst climate criminals on the planet.
This is the most politically incorrect thing possible, is to doubt this climate change orthodoxy.
If we look at climate through the geological time frame, we would never suspect CO2 as a major climate driver.
None of the major climate changes in the last 1,000 years can be explained by CO2.
We can't say that CO2 will drive climate. It certainly never did in the past.
I've often heard it said that there is a consensus of thousands of scientists on the global warming issue and that humans are causing a catastrophic change to the climate system. Well, I am one scientist, and there are many that simply think that is not true.
It is the story of the distortion of a whole area of science.
Climate scientists need there to be a problem in order to get funding.
We have a vested interest in creating panic because then money will flow to climate science.
The whole global warming business has become like a religion. And people who disagree are called heretics. I'm a heretic. The makers of this program are all heretics.
We are told that the Earth's climate is changing. But the Earth's climate is always changing. In Earth's long history, there have been countless periods when it was much warmer and much cooler than it is today, when much of the world was covered by tropical forests or else vast ice sheets. The climate has always changed, and changed without any help from us humans. Going back in time further still, before the medieval warm period, we find more warm spells, including a very prolonged period during the Bronze Age, known to geologists as the Holocene maximum, when temperatures were significantly higher than they are now for more than 3 millennia.
If we go back 8,000 years in the Holocene period, our current interglacial, it was much warmer than it is today. Now, the polar bears obviously survived that period. They're with us today. They are very adaptable, and these warm periods in the past, what we call hypsithermals, pose no problem for them.
Climate variation in the past is clearly natural. So why do we think it's any different today? So how does the industrial story compare with the temperature record? Since the mid-19th century, the Earth's temperature has risen by just over ½ degree Celsius. But this warming began long before cars and planes were even invented. What's more, most of the rise in temperature occurred before 1940, during a period when industrial production was relatively insignificant. After the Second World War, during the post-war economic boom, temperatures, in theory, should have shot up. But they didn't. They fell. Not for 1 or 2 years, but for 4 decades. In fact, paradoxically, it wasn't until the world economic recession in the 1970s that they stopped falling.
CO2 began to increase exponentially in about 1940, but the temperature actually began to decrease 1940, continued till about 1975. So this is the opposite relation. When the CO2 is increasing rapidly, but yet the temperature is decreasing, then we cannot say that CO2 and the temperature go together.
Why do we suppose that carbon dioxide is responsible for our changing climate? CO2 forms only a very small part of the Earth's atmosphere. In fact, we measure changes in the level of atmospheric CO2 in tens of parts per million.
If you take CO2 as a percentage of all the gases in the atmosphere, the oxygen, the nitrogen, and argon, and so on, it's 0.054%. It's an incredibly small portion. And then, of course, you've got to take that portion that supposedly humans are adding, which is the focus of all the concern, and it gets even smaller.
So the recent warming of the Earth happened in the wrong place and at the wrong time. Most of the warming took place in the early part of the 20th century and occurred mostly at the Earth's surface, the very opposite of what should have happened according to the theory of man-made global warming.
I am Al Gore. I used to be the next president of the United States of America.
Former Vice President Al Gore's emotional film, An Inconvenient Truth, is regarded by many as the definitive popular presentation of the theory of man-made global warming. His argument rests on one all-important piece of evidence taken from ice core surveys in which scientists drilled deep into the ice to look back into Earth's climate history hundreds of thousands of years. The first ice core survey took place in Vostok in the Antarctic. What it found, as Al Gore correctly points out, was a clear correlation between carbon dioxide and temperature.
We're going back in time now, 650,000 years. Here's what the temperature has been on our Earth. Now, one thing that kind of jumps out at you is, did they ever fit together? Most ridiculous thing I've ever heard. The relationship is actually very complicated, but there is one relationship that is far more powerful than all the others, and it is this. When there is more carbon dioxide, the temperature gets warmer.
Al Gore says the relationship between temperature and CO2 is complicated, but he doesn't say what those complications are. In fact, there was something very important in the ice core data that he failed to mention. Professor Ian Clarke is a leading Arctic paleoclimatologist who looks back into the Earth's temperature record tens of millions of years.
When we look at climate on long scales, we're looking for geological material that actually records climate. If we're to take an ice sample, for example, we use isotopes to reconstruct temperature, but the atmosphere that's imprisoned in that ice, we liberate, and then we look at the CO2 content.
Professor Clarke and others have indeed discovered, as Al Gore says, a link between carbon dioxide and temperature. But what Al Gore doesn't say is that the link is the wrong way round.
So here we're looking at the ice core record from Vostok, and in the red we see temperature going up from early time to later time at a very key interval when we came out of a glaciation. And we see the temperature going up, and then we see the CO2 coming up. CO2 lags behind that increase. It's got an 800-year lag, so temperature is leading CO2 by 800 years.
There have now been several major ice core surveys. Every one of them shows the same thing. The temperature rises or falls, and then, after a few hundred years, carbon dioxide follows.
So obviously, carbon dioxide is not the cause of that warming. In fact, we can say that the warming produced the increase in carbon dioxide.
CO2 clearly cannot be causing temperature changes. It's a product of temperature. It's following temperature changes.
The ice core record goes to the very heart of the problem we have here. They said, if the CO2 increases in the atmosphere as a greenhouse gas, then the temperature will go up. But the ice core record shows exactly the opposite. So the fundamental assumption, the most fundamental assumption of the whole theory of climate change due to humans is shown to be wrong.
But how can it be that higher temperatures lead to more CO2 in the atmosphere? To understand this, we must first restate the obvious point that carbon dioxide is a natural gas produced by all living things.
Few things annoy me more than to hear people talking about carbon dioxide as being a pollutant. You're made of carbon dioxide. I'm made of carbon dioxide. Carbon dioxide is how living things grow.
What's more, humans are not the main source of carbon dioxide.
Humans produce a small fraction in the single digits percentage-wise of the CO2 that is produced in the atmosphere.
Volcanoes produce more CO2 each year than all the factories and cars and planes and other sources of man-made carbon dioxide put together. More still comes from animals and bacteria, which produce about 150 gigatons of CO2 each year, compared to a mere 6.5 gigatons from humans. An even larger source of CO2 is dying vegetation, from falling leaves, for example, in the autumn. But the biggest source of CO2 by far is the oceans. Carl Wunsch is Professor of Oceanography at MIT. He was also visiting professor in oceanography at Harvard University and University College London, and a senior visiting fellow in mathematics and physics at the University of Cambridge. He is the author of 4 major textbooks on oceanography.
The ocean is the major reservoir into which carbon dioxide goes when it comes out of the atmosphere, or from which it is re-emitted to the atmosphere. If you heat the surface of the ocean, it tends to emit carbon dioxide. So similarly, if you cool the ocean surface, the ocean can dissolve more carbon dioxide.
So the warmer the oceans, the more carbon dioxide they produce, and the cooler they are, the more they suck in. But why is there a time lag of hundreds of years between a change in temperature and a change in the amount of carbon dioxide going into or out of the sea? The reason is that oceans are so big and so deep, they take literally hundreds of years to warm up and cool down. This time lag means the oceans have what scientists call a memory of temperature changes.
The ocean has a memory of past events running out as far as 10,000 years. So, for example, if somebody says, "Oh, I'm seeing changes in the North Atlantic," this must mean that the climate system is changing. It may only mean that something happened in a remote part of the ocean decades or hundreds of years ago, whose effects are now beginning to show up in the North Atlantic.
The current warming began long before people had cars or electric lights. In the past 150 years, the temperature has risen just over half a degree Celsius. But most of that rise occurred before 1940. Since that time, the temperature has fallen for 4 decades and risen for 3. There is no evidence at all from Earth's long climate history that carbon dioxide has ever determined global temperatures. But if CO2 doesn't drive Earth's climate, what does? The common belief that carbon dioxide is driving climate change is at odds with much of the available scientific data. Data from weather balloons and satellites, from ice core surveys, and from the historical temperature records. But if CO2 isn't driving climate, what is?
Isn't it bizarre to think that it's humans, you know, when we're filling up our car, turning on our lights, that we're the ones controlling climate? Just look in the sky. Look at that massive thing, the sun. Even humans at our present 6.5 billion are minute relative to that.
In the late 1980s, solar physicist Piers Corbyn decided to try a radically new way of forecasting the weather. Despite the huge resources of the official Met Office, Corbyn's new technique consistently produced more accurate results. He was hailed in the national press as a super weatherman. The secret of his success was the sun.
The origin of our solar weather technique of long-range forecasting came originally from study of sunspots and a desire to predict those. And then I realised it was actually much more interesting to use the sun to predict the weather.
Sunspots, we now know, are intense magnetic fields which appear at times of higher solar activity. But for many hundreds of years, long before this was properly understood, astronomers around the world used to count the number of sunspots in the belief that more spots heralded warmer weather. In 1893, the British astronomer Edward Maunder observed that during the Little Ice Age, there were barely any spots visible on the Sun, a period of solar inactivity which became known as the Maunder minimum. But how reliable are sunspots as an indicator of the weather?
Okay, bye. I decided to test it by gambling on the weather through William Hill against what the Met Office said was a normal expectation. And I won money month after month after month after month. Last winter the Met Office said it could be or would be an exceptionally cold winter. We said, no, that is nonsense, it's going to be very close to normal. And we specifically said when it would be cold, i.e. after Christmas and February. We were right, they were wrong.
In 1991, senior scientists at the Danish Meteorological Institute decided to compile a record of sunspots in the 20th century and compare it with the temperature record. What they found was an incredibly close correlation between what the sun was doing and changes in temperature on Earth. Solar activity, they found, rose sharply to 1940, fell back for 4 decades until the 1970s, and then rose again after that.
When we saw this correlation between the temperature and solar activity or sunspot cycle lengths, then people said to us, okay, it can be just a coincidence. So how can we prove that it's not just a coincidence? Well, one obvious thing is to have a longer time series or different time series. Then we went back in time.
So Professor Friis Christiansen and his colleagues examined 400 years of astronomical records to compare sunspot activity against temperature variation. Once again, they found that variations in solar activity were intimately linked to temperature variation on Earth. It was the sun, it seemed, not carbon dioxide or anything else, that was driving changes in the climate. In a way, it's not surprising. The sun affects us directly, of course, when it sends down its heat. But we now know the sun also affects us indirectly through clouds. Clouds have a powerful cooling effect, but how are they formed? In the early 20th century, scientists discovered that the Earth was constantly being bombarded by subatomic particles. These particles, which they called cosmic rays, originated, it was believed, from exploding supernovae far beyond our solar system. When the particles coming down meet water vapor rising up from the sea, they form water droplets and make clouds. But when the sun is more active and the solar wind is strong, fewer particles get through and fewer clouds are formed. Just how powerful this effect was became clear only recently, when an astrophysicist, Professor Nir Shaviv, decided to compare his own record of cloud-forming cosmic rays with the temperature record created by a geologist, Professor Jan Weitzer, going back 600 million years. What they found was that when cosmic rays went up, the temperature went down. When cosmic rays went down, the temperature went up. Clouds and the Earth's climate were very closely linked. To see how close, you just flip the lines.
We just compared the graphs, just put them one upon the other, and it was just amazing. Jan Weitzer looked at me and says, you know, we have very explosive data here.
I've never seen such vastly different records coming together so beautifully to show really what was happening over that long period of time.
The climate was controlled by the clouds. The clouds were controlled by cosmic rays. And the cosmic rays were controlled by the sun. It all came down to the sun.
If you had X-ray eyes, what appears as a nice, friendly yellow ball would appear like a raging tiger. The sun is an incredibly violent beast, and it's throwing out great explosions and puffs of gas, and endless solar wind that's forever rushing past the Earth. We're, in a certain sense, inside the atmosphere of the sun. The intensity of its magnetic field more than doubled during the 20th century.
In 2005, astrophysicists from Harvard University published the following graph in the official journal of the American Geophysical Union. The blue line represents temperature change in the Arctic over the past 100 years. And here is the rise in carbon dioxide over the same period. The two are not obviously connected. But now look again at the temperature record, and at this red line, which depicts variations in solar activity over the past century as recorded independently by scientists from NASA and America's National Oceanic and Atmospheric Administration.
Solar activity over the last 100 years, over the last several hundred years, correlates very nicely on a decadal basis with sea ice and Arctic temperatures.
To the Harvard astrophysicists and many other scientists, the conclusion is inescapable.
The sun is driving climate change. CO2 is irrelevant.